Welcome back. This lesson is about some of Python's inner mechanics, how it evaluates objects at runtime, and common mistakes you may face when writing your first lines of code. Python is considered a high-level programming language, which means that it was designed to be easy for people to read, write, and understand. It abstracts low-level details away from the developers, which in other languages may include defining the memory allocated to variables or deciding when the same variables should be freed from the computer. One of these high-level features include implicit Boolean evaluation, meaning how Python implicitly evaluates certain objects as true or false when evaluated against the Boolean function, even though the original object may be far from being a Boolean in the first place. Let me try to explain with a quick example. Let's say I create an empty list containing all my dreams and ambitions. I can create an if-else snippet based on the length of this list, which evaluates if it is empty and performs the follow-up actions. Here we are evaluating the condition length dreams is bigger than 0, which is converted to a Boolean, either true or false. However, Python has a simpler way to translate the condition of emptiness into a Boolean value. In this case, for example, if I want to evaluate as a Boolean, I just use the if statement and I evaluate the dreams variable directly. In fact, there are a bunch of default values that evaluate as false in if statements, while loops, or other logical operators. We call this particular group of objects as being falsy. In this next example, I present you the falsy types and respective values available to you in Python. None and false evaluate to false, which is not surprising. But we also have numeric values that represent 0, as well as empty strings or byte values. Lastly, we have the empty collections, which we covered in past lessons. Lists, tuples, sets, and dictionaries, and even ranges can all be falsy when they are empty. This means that they will evaluate to a false condition when using the if statement. We tend to associate falsy to being empty, 0, or null. By default, everything that is not falsy is truthy. Quick test for you. If I evaluate a list with an empty string as a Boolean, will it return true or false? Feel free to pause the video. It returns true since the list is not empty, even though its value is. As a side note, you can always use some of Python's built-in functions, such as any and all, to evaluate truthy and falsy to a group of values. Let's say here that I want to evaluate if any of the values in my list is true. For that, I use the function any. In this case, because I have a number that is 0, I have none, I have the Boolean false, and I have empty strings, the result will be false, meaning that none of these values is true or truthy. Its counterpart, the built-in function all, returns true if all the values are true. Note here again that my third object is a list that contains 0, even though 0 is evaluated as falsy, because I have a list with an item, that list is evaluated to true or truthy. Before finishing the lesson, I wanted to briefly mention two of the most used comparison methods in Python, which you'll often use. These are the identity operator and the equality operator. The identity operator compares if any two objects are exactly the same, meaning that they share the same memory address in your computer. Think of memory address as the location in memory where that object is stored. In the context of this course, we'll most likely only use this operator to check if an object is none. None is special in Python, and it is what we call a singleton, which means there is only one instance of it in your Python program. Any new object that we set to none is essentially using the same memory address, which you can see by calling the function id. But remember, none is a special case. The vast majority of objects, while sharing the same contents, will have different identities or IDs, meaning they will have different memory addresses. For example, if we have two lists, y and z, with the same contents, I can see that their memory addresses are different. And as such, using the identity operator is will return false. For these cases, we use the equality or contents operator, which is described by the two equals put together. If we do it and print the result of the operation, we can see that its outcome is true. Think of the equality or contents operator as two people wearing the same clothes. They may have the same shoes, pants, and shirt, but they are still different people at the end of the day. If that wasn't the case, the moment you'd update one of the objects, the other would also change. And for the most part, we don't want that to happen. Alright, this wraps up this lesson. I hope you have enjoyed it.